Today we are going to do sequences, chapter 5, which is on 5.1 on page 428. Now sequences are completely different from what we have been doing so far. So far we've been doing a lot of integration, right? And right when we had enough of integration, we had to do more. But so now we're going to take a nice little break and start doing something called sequences, which has practically nothing to do with integration, so you don't have to integrate for a while and can take a break. So what are sequences? Sequences are a bunch of numbers. That's all they are. The bunch of numbers might follow a certain rule, such as 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, right? That follows set rules. Or it might not follow anything at all. It's just a bunch of stuff. And that can also be called a sequence. So basically, a sequence is a list of numbers. That's all it is. And then the one after, or a line, like somebody standing in line, you have the first one, second one, third one, and so on. So that goes on and maybe indefinitely. So that, we mostly care about sequences that go on forever. Okay, if it stops, it's just a list. We don't really care as much. Specifically, we consider the so-called infinite sequence on page 428. Please read about the terminology. I'm not going to go over that because I mostly don't remember it myself until it comes up. So sequences are a bunch of numbers, could be anything. And sometimes they have specific rules on how the numbers can come on. So that's a neat little sequence instead of just a list of random numbers. That doesn't make much sense. Now, specifically of the ones that have rules, there's something called a geometric sequence. Please look at the bottom of page 429. A geometric sequence is something where the ratio of each term is constant. For example, let's look at a quick example of a geometric sequence at the bottom of the page where you have 2. Okay, the first number is 2. Okay, and then the second number you divide it by 3. The third number you divide the second number by 3, and you keep doing that. So the ratio is constant between the terms. Okay, the ratio is always 3 or 1/3 or whatever it is. Yeah, 1/3 in this case. And if that is the case, the sequence is called the geometric sequence. All right. So then next we have so now that we kind of have an idea of what a sequence is, we can look at some of the sequences. Let's look at example 5.1 in the following page. Now, example 5.1, we're supposed to find some formula for the sequence. If a sequence follows a specific rule, sometimes we can have a formula for it. For example, let's look at the previous page to see what I mean exactly. For example, you have a formula is, all right, let's look at that one. Okay, the geometric sequence that we just looked at, the formula is this. Look at the bottom of the page. You can also look at your own book, of course. So A1 equals to 2, and then AN is just minus 1/3 times AN minus 1. That is, to calculate the next term, you multiply minus 1/3 to the previous term. So the first term is 2, the second term is multiplied by minus 1/3, which becomes 2/3, and then you multiply by minus 1/3 again for the third term, and you keep doing that forever. So that formula describes completely what the entire sequence is about. And so then, as you can imagine, you can come up with formulas for sequences that follow a certain rule. So let's look at example 5.1. Example 5.1, you have a bunch of stuff, right? What would the formula be? And the formula is, look at part A, okay? Then the formula, take a look at this, right? What is A of n? Now, the first one is just one, on top is just n, right? 1, 2, 3, 4, 5. What's it on the bottom? On the bottom is just a little bit different. So is A, the bottom is basically n minus 1, and you have to take care of the sign. It goes from negative to plus and keeps switching. So to take care of that, you got to multiply by minus 1 to the power n. And that's how you solve part A. And part B is very similar. So I will let you do example 5.1 as part of your homework to see how to come up with a formula for your sequence. Now next, let's look at a different kind of formula. Well, actually, we did see it a little earlier in the geometric sequence, that you can define some a sequence. You talk about the first term, A1, what it is, and then the next term is defined up in some way related to the term right before it. For example, let's look at the example 5.2 part A, okay, where A1 is 2, which is fine, right? A1 is some fixed number, and then from that point on, AN equals to minus 3 of the AN minus 1, that is the A before it. So what is A2? Then A2 is minus 3 times A1, which is minus 6, which is fine. And then A3 is minus 3 times A2, then you'll do, that's 9 times 2 is 8, positive 18, and so on. You just keep going there. So then you can, so in that case, therefore, looking at the pattern, then you can actually write the explicit formula. So I guess for this problem, we're trying to go from the recursive formula, which is just defined by the formula before it, then some kind of a general formula where you just plug in the n right in for any number and the whole thing will come out. And so yeah, so these are fairly simple recursive problems, I guess. So I will let you do problems, do example 5.2 for homework.